Welcome to C Programming Lecture 13. In this lecture, we will look into the sequential and random access files processing in C programming language. Creating, amending, reading of files in the secondary memory storage are in general called the file processing. So far in all the example C programs we have looked into in the lectures have taken input only from the keyboard and displayed the result on the monitor. File processing will help C programs to read data from a file and or write data into a file stored in the secondary memory like the hard disk or solid-state memory device. C programs can process two different types of file called the sequential file and random access file. Sequential file can be read by other C programs and other apps like text editors, Excel, MATLAB, LaTeX for further processes. Random access file can only be read by other C programs for further processes. To learn how to create a sequential file in C programming language, let us consider the C program that dynamically allocates the memory for a three-dimensional array and the elements of the array are taken through the keyboard. This C program is almost similar to the Lec 12 Statement 11.C program we looked into at the end of Lecture 12. Difference is that the 3D array is finally written in a new sequential file created by this C program. In line 7. The function name is changed appropriately to save3d-array. Function named save3d-array is with first parameter as a pointer to a pointer to a pointer referring to the memory allocated to store the three-dimensional array. Second, third and fourth parameters are the integers that receive the number of layers, rows and columns in the 3D array. In the main function after receiving all the elements of the 3D array, in line 45 function save3d-array is invoked. Save3d-array function is invoked with pointer to a pointer to a pointer a and variables lay, row and col, which have the number of layers, rows and columns of the three-dimensional array A. In the save3d-array function, in line 67, file pointer ptr3d is declared. In a C program when a file is created or opened then we need a handler that can refer to the file memory location. In the C program, file pointer ptr3d will be used to refer to a sequential file created to write the elements of the 3D array passed on to the save3d-array function. In the save3d-array function, lines 82 to 103 are written as if-else double selection statements to create a sequential file and print the 3D array elements. It is a good practice to check the condition for the successful opening of the file to perform file processing like writing or reading or amending. If the file cannot be opened then the program can display appropriate message and not stop processing any file. Line 82 is the first line of the if-else statement that is checking the condition whether the file opening is not successful. fopen is a function that requires two parameters for performing the file processing for either writing or reading or amending. First parameter is the file name and the second parameter is the attribute for the type of the file and processing. Both these parameters are written within their respective double quotes and separated by a comma. In the first parameter if no file path is specified, then the file will be processed in the same folder as that of the C program. For the second parameter for the file attribute there are two different sets of alphabet characters available respectively for the sequential file and random access file. For the sequential file attributes, W is available for creating and writing in a new file, R is available for reading from an existing file and O is available to write more data at the end of the already existing file. For the random access file attributes, WB is available for creating and writing in a new file, RB is available for reading from an existing file and AB is available to write more data at the end of the already existing file. Here, fopen function in line 82 will create a sequential file with a name 3darray.txt in the same folder as that of the C program. If the file cannot be created, then null will be returned. So, the line 82 if statement condition will be satisfied when the file cannot be created. When file is successfully created, then its memory address will be assigned to the file pointer ptr3d. And hence the file pointer ptr3d can be used to perform the appropriate file processing in the rest of the C program. Here, the file name extension is written as .txt for the ease of opening it using any standard text editor's app. If the file cannot be created, then null will be returned. This will make the if condition satisfied. Within the body of the if statement and line 84, printf statement is written to display the message on the monitor that file could not be opened. If the file can be created, then file pointer ptr3d assigned to refer the sequential file name 3darray.txt can then be used for writing on it. This will make the if condition not satisfied and the statements written within the else body will be selected. Within the body of the else statement and lines 88 to 102, nested 3 for loops and printf statements are written in the sequential file name 3darray.txt using the file pointer ptr3d. The way 3D array displayed on the monitor using 3 nested for loops layer by layer was explained through C program named lec12 for statement 11.c in lecture 12. For saving the 3D array in a sequential file, similar lines are to be written with only change as using fprintf instead of printf statement. In lines 94, 96 and 98. Fprintf statements are written with file pointer ptr3d file pointer as the first parameter to write the third parameter content as per the second parameter format in the sequential file. So, the only difference between the printf and fprintf statement is that the fprintf statement is the file pointer referring to the sequential file as the extra first parameter. Within the scope of the else statement, finally, after saving the 3D array in the sequential file, in line 102, that message is displayed on the monitor. As the job of saving the 3D array in the sequential file is performed by the save3d function, the file opened need to be closed. In line 104, fclose function is called with the file pointer ptr3d which will close the sequential file name 3darray.txt. Display of the execution of the exe file, input of the layer, row and column numbers of the 3D array, 24 elements one by one, and final output are shown in the inset window. In addition, a sequential file named 3darray.txt is created in the same folder as that of the C program, and in which the 3D elements are written. To learn how to create a random access file in C programming language, let us consider the C program that generates coordinates points to plot sinusoid wave. This C program will first take the units for the phase angle as degrees or radians. The peak amplitude of the sinusoid wave to be plotted is received as the next input through the keyboard. The frequency of the sinusoid wave to be plotted is received as the next input through the keyboard. Period of the sinusoid wave can be calculated as the reciprocal of the frequency. The constant phase angle of the sinusoid wave to be plotted is received as the next input through the keyboard. If the chosen units for the phase angle is degrees, then the phase angle will be converted in terms of radians for the calculation of the data points to plot the sinusoid wave. Number of cycles of the sinusoid wave to be plotted is received as the last input through the keyboard. The sample sinusoid wave shown here is plotted for 4 cycles. In the C program, a structure is defined with a pointer to request necessary memory to store the 2D sinusoid wave data points and all necessary variables that are needed for the processing of the computed sinusoid data points. This structure is saved as a random access file that can be read only by C programs. Then, this lec13 file processing 2.c program computes the sinusoid data points and save it in a sequential file that can be read by other C programs or apps like Excel or MATLAB. Finally, the C program creates another sequential file with required MATLAB code lines to read the sinusoid data points sequential file and plot the sine wave as per the input parameters fed through the keyboard. In line 7 to 12, a structure named as signal is defined with a pointer to pointer and all necessary variables that are needed for any further processing of the computed sinusoid data points by this C program. In the structure signal, data is a double type pointer to pointer that will request the necessary memory to store the 2D sinusoid wave data points. First column of the 2D array is for the horizontal axis time data points, and the second column is for the vertical axis time varying amplitude of the sine wave. In the structure signal, A is a double type variable that will be used for the peak amplitude of the sine wave. In the structure signal, F is a double type variable that will be used for the frequency of the sine wave. In the structure signal, D is a double type variable that will be used for the constant phase angle of the sine wave. In the structure signal, CYC is a double type variable that will be used for the number of cycles of the sine wave. In the structure signal, pi is a double type variable that will be used for the computation of angular frequency of the sine wave. In the structure signal, W is a double type variable that will be used for the angular frequency of the sine wave. In the structure signal, T is a double type variable that will be used for the period of the sine wave. In the structure signal, T0 is a double type variable that will be used for the total time window, which is calculated as the product of sine wave period and number of cycles. In the structure signal, Fmax is a double type variable that will be used for the total frequency window, which is calculated as 20 times the frequency of the sine wave. 20 times is the amount of scaling factor to cover enough frequency components on either side of the fundamental sine wave frequency. Having enough amount of frequency window is very important when developing algorithm for the simulation of any signals and systems. That may involve dynamics, which can have increase or decrease of the signal frequency with respect to the frequency components of the initial signal. In the structure signal, dt is a double type variable that will be used for the time sampling interval, which is calculated as the reciprocal of the twice the amount of the frequency window f maximum. Calculation of the time sampling interval in this way will take Nyquist criterion into consideration and avoid aliasing in the frequency domain. In the structure signal, df is a double type variable that will be used for the frequency sampling interval, which is calculated as the reciprocal of the time window t0. Calculation of the frequency sampling interval in this way will take Nyquist criterion into consideration and avoid aliasing in the time domain. In the structure signal, n is an integer type variable that will be used for the total number of sample points, which is calculated as the ratio of the time window t0 to the time sampling interval dt. Calculation of the total sample points in this way may not result in an amount that can be expressed in terms of 2 raised to the power of a whole number. To facilitate fast Fourier transform using radix 2 butterfly algorithm, the calculated total sample points n to be adjusted to the nearest higher integer value that can be expressed in terms of 2 raised to the power of a whole number. In the structure signal, n is an integer type variable that is related to the total number of sample points n. 2 raised to the power of lowercase n is equal to the uppercase n, which is the total sample points. Both lowercase n and uppercase n can be used to implement the fast Fourier transform radix 2 butterfly algorithm. In line 13, using typedef, the type definition of structure signal is made a signal to ease the declaration of structures of type signal further in the code. Note the uppercase s and lowercase s are respectively used in the structure name signal and its typedef name signal. In line 16, the prototype of a function named signal generator is written. Definition of the function signal generator is written after the main function from line 45. Note the function signal generator can be called with a structure of type signal and returns void. Within the main function in line 20, a structure of type signal is declared as sign. In line 21, a variable of type character is declared as units, which will be used for the units for the constant phase angle either as degrees or radians. In line 22, an one-dimensional array of type character is declared as deg or rad, which is stored with the string degrees. During execution, if the user selection of the units is radians, then this array of characters will be changed appropriately with the string radians. In line 24, assignment statement, irrational number pi value is calculated and assigned to the double variable sign.pi, which is one of the elements of the structure sign. Note that dot operator is used between the structure name sign and element name pi to appropriately assess the required quantity that belongs to the structure. In line 27, printf statement, user is prompted to input either character D or R for the choice for the constant phase angle units. In line 28, scanf statement, user input character either D or R for the choice for the constant phase angle units is stored at the memory location allocated for the variable units. To make it as a better written code, the printf and the scanf pair of statements can be written within a do-while repetition loop, and an if condition statement could be written to check the validity of the character input by the user. In line 29, if condition statement, the variable unit's character value is checked for alphabet R. And if the condition is true, array deg or rad contents are changed from degrees to radians, using sprintf statement. Note that no braces were used for the body of the if statement, as it is a single line statement and ended with a semicolon. In line 32, printf statement, user is prompted to input AC sine wave signal amplitude, frequency, constant phase angle and the number of cycles. Note the use of array deg or rad contents to specify the units for the constant phase angle as chosen by the user. In line 33, scanf statement, user input AC sine wave signal amplitude, frequency, constant phase angle and the number of cycles are stored at the memory location allocated at the respective elements of the structure sign. To make it as a better written code, the printf and the scanf pair of statements can be written within a do-while repetition loop, and appropriate checking condition statements could be written to check the validity of the inputs by the user. In line 34, if condition statement, the variable unit's character value is checked for alphabet D. And if the condition is true, sign.d constant phase angle value is converted from degrees to radians, using assignment statement. Note that no braces were used for the body of the if statement, as it is a single line statement and ended with a semicolon. Now, all the parameters for calculating the sine wave signal data are available in structure sign of type signal. In line 37, function signal generator is called with the structure sign. In the definition of the function signal generator, necessary lines are written to calculate the AC sine wave signal data points and for file processing to save the data points. From line 37, function signal generator is called by value with the structure sign, which was declared in the main function. So, The structure sign from the main function is copied to the structure sign in the function signal generator, whose definition is written from line 45. In the definition of the function signal generator, in line 47, running variable I is declared. In line 48, file pointer sign ptr is declared. This file pointer can be used to point any file that needs to be processed to save data. In line 49, one-dimensional character type array sign file is declared and its memory contents is stored with string sign data.txt. This string will be used as the file name in the file processing to save data points calculated for the AC sine wave. In line 51, sine.w is assigned with the calculated value of the angular frequency of the sine wave. Angular frequency is calculated as 2 times pi times f. In line 53, sine.t is assigned with the calculated value of the time period of the sine wave. Time period is calculated as 1 over f. In line 54, sine.t0 is assigned with the calculated value of the time window to plot the sine wave. Time window is calculated as time period times number of cycles. In line 55, sine.df is assigned with the calculated value of the frequency sampling interval. Frequency sampling interval is calculated as 1 over time window. In line 56, sine.fmax is assigned with the calculated value of the frequency window. Frequency window is calculated as 20 times sine wave frequency to satisfy Nyquist criterion for avoiding aliasing in the time domain. In line 57, sine.dt is assigned with the calculated value of the time sampling interval. Time sampling interval is calculated as 1 over twice the amount of frequency window to satisfy Nyquist criterion for avoiding aliasing in the frequency domain. In line 59, sine.n is assigned with the calculated value of the total number of sample points. Total number of sample points is calculated as time window over time sampling interval. Total number of sample points calculated as the ratio of the time window t0 to the time sampling interval dt may not result in an amount that can be expressed in terms of 2 raised to the power of a whole number. To facilitate fast Fourier transform using radix 2 butterfly algorithm, the calculated total sample points n to be adjusted to the nearest higher integer value. With lines written in lines 60 to 64, the whole number that can achieve this adjustment of total sample points n to be the nearest higher integer value is calculated. To begin with, in line 60, sine.n is assigned as 1. In line 61 to 64, within a while repetition loop, sine.n is incremented in steps of 1. Until the condition sine.n is greater than 2 raised to the power of sine.n is satisfied. In line 65, total number of sample points, sine.n is assigned with the recalculated value of 2 raised to the power of sine.n. Both lowercase n and uppercase n can be used to implement the fast Fourier transform radix 2 butterfly algorithm. In line 66, time sample interval, sine.dt is assigned with the recalculated value of sine.t0 over sine.n. Now, all the numerical parameters required for sampling a continuous time varying signal are appropriately calculated by taking into consideration of the Nyquist criterion in both time and frequency domain. AC sine wave signal data is ready to be computed and saved, which can be used for further signal processing and or plotting the 2D graph of the sine wave. Continuous wave signal like sine wave is a function varying with respect to time, so the n number of data points has to be prepared as a 2-dimensional data points corresponding to time data point and the respective sine wave function value. In line 69, To store the data points in the 2D array sign.data, required n amount of memory is allocated using malloc function. In line 71 to 74, to store the data points in the 2D array sign.data, required 2 per every data point amount of memory is allocated using malloc function within a for repetition loop. In line 77 to 81, within a for loop, sample time and sine wave signal n data points are calculated and assigned to the appropriate elements of the sign.data 2D array. In line 79, n time data points are calculated and assigned to the first elements of the sign.data 2D array. Time data points are calculated as the product of the running variable and time sample interval. In line 80, n sine wave signal data points are calculated and assigned to the second elements of the sign.data 2D array. Sine wave signal data points are calculated through the sine mathematical function available in math.h standard library function. Note that the sine wave signal parameters, amplitude, angular frequency, constant phase angle are appropriately used in the sine mathematical function, along with the time data points. In lines 84 to 92, necessary statements are written to create a random access file and the structure sign of type signal is saved in that. In lines 84 to 87, if statement is written with the checking condition to create a random access file and if the file cannot be created, that message is displayed on the monitor. This way of using if condition to check successful creation of file processing should be practiced as a standard procedure for both random access file or sequential file. In line 84, random access file is created in the name of sign parameters.dat using fopen function and the memory address where it is created is assigned to the file pointer sign ptr. Note that file attribute wb is used to create a random access file. In the file attribute wb, w stands for write and b stands for binary. In lines 88 to 91, else statement is written with necessary lines to save the structure sign of type signal in the successfully created random access file. In line 90, fwrite function is written with 4 different necessary arguments to save the structure sign of type signal in the sign parameters.dat random access file. Note that, in this case of random access file writing, fwrite statement is used in the place of fprintf statement corresponding to sequential file. First argument in the fwrite function is the pointer of the structure sign, which will provide the memory address from where the contents to be taken from to write it in the random access file. Second argument in the fwrite function is the size of the contents to be transferred. In this case, as it is the size of the structure sign of type signal, size of signal is written for single size of the structure sign. Third argument in the fwrite function is the number of elements to be transferred. In this case, 1 is written as only one quantity of structure sign to be transferred. Fourth argument in the fwrite function is the file pointer pointing to the random access file. In this case, sign ptr is written, which points to the random access file sign parameters.dat. In line 92, fclose function is written with file pointer name sign ptr as the argument to close the random access file. It is a good practice to close the file once the file processing is completed. Thus, through the lines 84 to 92, necessary statements are written to create a random access file and the structure sign of type signal is saved in that. After the successful compilation and execution of the C program, a random access file in the name of sign parameters.dat will be available in the same folder as the executable file. In this example only one structure has been written, but as necessity arises, as many structures of the same type can be written and randomly any particular structure can be accessed to write or read. In lines 95 to 106, necessary statements are written to create a sequential file and the sine wave signal two-dimensional data corresponding to time and sine function value are saved in it. Note that, in the random access file created and saved through lines 84 to 92, the sine.data element in the structure sine has pointed to the starting memory address of the 2D array. So, in the random access file the contents of the 2D array memory address location are not saved. The contents are the 2D data corresponding to the time and sine function value of the AC signal. Hence, the contents of the 2D array memory address location are saved separately as sequential file, which can be accessed by other C program or software packages like MATLAB. In line 95, sequential file is created in the name of sinedata.txt using fopen function and the memory address where it is created is assigned to the file pointer sineptr. Note that the file name sinedata.txt is availed through the character array variable sinefile, declared in line 49. Also, note that file attribute w is used to create a sequential file. File attribute w stands for write. In line 103, Printf statement is written within a for loop to save the time and sine function value separated by a tab space in the sequential file. Note that the specification used in the Printf statement is similar to Printf statement, with only extra argument as the file pointer as the first argument. Printf statement written within the for loop, repeating for n number of times will save all the sine wave signal data corresponding to time and sine function value line by line. After the successful compilation and execution of the C program, a sequential file in the name of sinedata.txt will be available in the same folder as the executable file. In line 106, as a good practice, open sequential file is closed using fclose function with file pointer as the argument. In lines 109 to 127, statements are written to create a sequential file written with the necessary MATLAB code to plot the sine wave signal data saved in the sinedata.txt sequential file. This MATLAB code sequential file can be written directly in the MATLAB editor. But here, it has been created through the C code to get more familiarized with creation of sequential file for various applications. After the successful compilation and execution of the C program, a sequential file in the name of plot sinedata.m will be available in the same folder as the executable file. These are the MATLAB code lines saved in the sequential file named plot sinedata.m. When the C program was compiled and executed, the character option chosen for phase angle units was R, followed by the sine wave parameters input for amplitude, frequency, constant phase angle and number of cycles were respectively 1, 50, 3.14 and 4. When the plot sinedata.m MATLAB file was executed, this figure was generated for the plot of the sine wave from the 2D data saved in the sinedata.txt sequential file. As the last step in this signal generator function, in lines 130 to 135, statements are written to orderly release the allocated 2D memory, using free function. Next in the file processing, let us write a C program that can read the sine parameters.dat random access file and sinedata.txt sequential file. Then, the sine wave signal 2D data corresponding to the time and the sine function value are then displayed on the monitor. When the sine parameters.dat random access file is read, the structure of type signal saved in it needs to be stored in a similar type of structure declared in the C program. In line 6 to 11, structure signal is defined in the exact same way as it was defined in the LEC 13 file processing 2.c. and then it is typed fAda signal in line 12. Within the main function in line 16, a structure of type signal is declared as sign. This is useful to read the structure saved in the random access file sign parameters.dat. In line 18, a file pointer is declared as sign ptr. This is useful to handle the random access file sign parameters.dat and sequential file sign data.text. In lines 21 to 29, necessary statements are written to read from the random access file sign parameters.dat. Note that the statements include the checking of the successful opening and closing of the file once the file processing is completed. In line 21, random access file sign parameters.dat is open to read from it using fopen function, and its memory address is assigned to the file pointer sign ptr. Note that file attribute RB is used to read from the random access file. In the file attribute RB, R stands for read and B stands for binary. In line 27, fWrite function is written with 4 different necessary arguments to read one amount of contents of size signal from the sign parameters.dat random access file. And that contents is to be stored in the memory address location of the structure sign. Note that these 4 arguments are same as what we used to write in the random access file. Here, the difference is that the fRead function will make the transfer of the contents from the random access file to the structure sign. Also note that, to read from random access file, fRead statement is used in the place of fscanf statement corresponding to sequential file. All the sine wave signal parameters are now available in the elements of the structure sign that can be used for further processing, like reading the 2D data from the sign data.text sequential file. In lines 32 to 37, necessary statements are written using malloc function to get required amount of 2D memory allocated and in the address are appropriately assigned to the pointer sign.data. This 2D memory locations will be used to store the sine wave signal 2D data to be read from the sign data.text sequential file. In lines 40 to 51, necessary statements are written to read from the sequential file sign data.text. Note that the statements include the checking of the successful opening and closing of the file once the file processing is completed. In line 40, sequential file sign data.text is open to read from it line by line using fopen function, and its memory address is assigned to the file pointer sign ptr. Note that file attribute R is used to read from the sequential file. File attribute R stands for read. In line 48, fscanf statement is written within a for loop to read the time and sign function value from the sign data.text sequential file. Note that the specification used in the fscanf statement is similar to scanf statement, with only extra argument as the file pointer as the first argument. Fscanf statement written within the for loop, repeating for n number of times, will read all the sine wave signal data corresponding to time and sign function value line by line. At this point, the sine wave signal 2D data corresponding to time and sign function value are available in the allocated 2D memory location for any further required analysis and processing. In line 56, printf statement is written within a for loop to display the time and sign function value separated by a tab spacing. Printf statement written within the for loop, repeating for n number of times, will display all the sine wave signal data corresponding to time and sign function value line by line on the monitor. As the last step in the main function, in line 60 to 65, statements are written to orderly release the allocated 2D memory using free function. All the C programs examples discussed in this lecture are provided to learn about file processing. Try to write C programs yourself to get more practice. experience and confidence in coding computer programs. This completes all the lectures for the C programming. All the best and enjoy coding.